Hello students, today I will be going through Chapter 7 Functions and Graphs on the worksheet 5, which is Graphs in Practical Situations. So at the end of this lesson, you should be able to interpret and analyze graphs in daily life. So I'll start off with the first section, which is Graphs of Related Quantities. This means a visual representation on how two different quantities change in relation to one another. So I'll be doing question 1 now. Let's read the question. So the graph below shows the conversion of degrees Celsius into degrees Fahrenheit. So this graph is actually a representation on the unit conversion between two different temperature scales, degrees Celsius and degrees Fahrenheit. So let's zoom in. So if you notice, the vertical axis represents degrees Fahrenheit and the horizontal axis represents degrees Celsius. Now let's take a look at part A. The boiling point of petrol is 95 degrees Celsius. What is the boiling point of petrol in degrees Fahrenheit? So I already given you in degrees Celsius, 95 degrees. So let's take a look at the horizontal axis. So 50 is here, 100 is here. So it's in between these two values. So there are 10 small squares between 50 and 100. That means one small square will represent 5. So over here will be 60, 70, 80, 90. So 95 it's here. So what I'll do is I will draw dotted line up to meet the line given here. Dotted line up until I meet the line, and then to find the corresponding value for degrees Fahrenheit, likewise you draw dotted line to the left till you meet the vertical axis. So you can use your ruler and pencil to do so, okay? So if you notice, it's about here, okay? So likewise, for the vertical axis, 10 small squares represent 50. So one small square represents 5. So if you notice, it's slightly below 205. So I will just take the midpoint of 200 and 205, which is 202.5 degrees Fahrenheit. Now let's move on to part B. The boiling point of ethanol is 30 degrees Fahrenheit less than the boiling point of petrol, which is already found in part A. But the question is asking you the boiling point of ethanol in degrees Celsius. So in degrees Celsius. So first step, we need to take 202.5 degrees Fahrenheit, subtract 30, and you will get 172.5 degrees Fahrenheit. Question asks you in degrees Celsius, so what we can do, let's locate 172.5 degrees Fahrenheit. So this is 160, 170, 180. So 172.5 degrees should be somewhere here. Slightly above 170. So what you can do, you can draw dotted line to meet the straight line, and then dotted line down to meet the horizontal axis, so that you can find the corresponding value for degrees Celsius. So over here, if you notice, it's about 3/4 to 80. So the value for this is 77.5. So the answer for part B from the graph is 77.5 degrees Celsius. So that is for part B. Now let's take a look at part C by drawing a suitable line on the graph. So we have to draw a line, find the approximate value for W given that W degrees Fahrenheit equals to W degrees Celsius. I'm going to zoom in into this equation here. W degrees Fahrenheit. So take note, Fahrenheit is represented on the vertical axis or the y-axis, while degrees Fahrenheit is the horizontal axis or also the x-axis. So if you notice, if I want degrees Fahrenheit equals to degrees Celsius, I have to draw the line of y equals to x. So you must be wondering, how do I draw the line y equals to x? For the line y equals to x, every y value, so let me just write here, every y value on line y equals to x will be equal to the x value, and it will also pass through the origin. So what I can do, I can draw a line that passes through this point 50, 50, where your x value 50 is equals to your y value of 50. I can also pass it through the origin and pass it through negative 50, negative 50. So let me just draw the line in red. So using your ruler and pencil, you can draw a straight line through these 3 points. And if you notice, this line y equals to x cuts the other line given at this particular point. So let's find the coordinates for this particular point here. You'll notice that the coordinates for this particular point is negative 40, negative 40. So this means your W here will be negative 40. So this is how you do part C. Now let's take a look at question 2. So question 2 is a graph that shows the monthly cost of electricity supplied by SparkLife. So this graph actually represents the cost versus the amount of electricity used. Cost will be represented on the vertical axis, units of electricity on the horizontal axis. So do take note, let's zoom in here first. So for the vertical axis, you notice that 5 small squares here represent $20 over here. So one small square represents $4. Whereas the horizontal axis, 800 to 1000, there are 10 small squares that represent 200 units of electricity. So one small square represents 20 units of electricity. And the line here is actually on SparkLife. Let's look at part A. Mr. Lim's electricity is supplied by SparkLife. He used 700 units of electricity in June. We have to use the graph to find the amount he was charged. So let's just zoom in to 700, which is in between 600 and 800. Draw dotted line up to meet the straight line. And then draw dotted line to the left to meet the vertical axis, so we can see the corresponding cost for 700 units of electricity. Okay, right over here. So just now I mentioned that one small square represents $4 for the vertical axis. So 124, 128, 132, 136. So the dotted lines actually meet between 132 and 136, which is 134. Let me just put an arrow here. 134. So the answer for part A will be, from the graph, $134. Now let's read part B. So now there is a new company called PowerSave. So take note, the line represented here, it represents SparkLife. So now a new company, PowerSave, charges a basic fee of $60 per month and then $0.112 per unit of electricity use. Let me explain what these two phrases mean, okay? So we look at SparkLife first. If you notice, for SparkLife, there is a y-intercept here, when 0 units of electricity used, I have to pay a payment. This is what we call the basic fee. So the basic fee for Spark Life is actually $16. So I'm going to write here, basic fee for Spark Life is $16. But for PowerSave, the basic fee is $60 per month. So that means the y-intercept for PowerSave will be here already. So let me just label PowerSave y-intercept. So the line will actually start from here. So because we need to draw a line to represent the cost of electricity supplied by PowerSave, we have to look at this phrase here. Per unit of electricity used, so this is cost per unit of electricity. This actually means the gradient. Why do I say so? I'm going to zoom out and go back to Spark Life. So if you notice, y-axis represents cost, x-axis represents units of electricity. So if we were to write the gradient formula for this particular graph, y-axis is cost over units of electricity, which is the x-axis. So let me recap. Gradient is y2 minus y1 over x2 minus x1. So change in the y values is actually change in the cost. Change in the x value is change in the units of electricity, which is why gradient is cost over units of electricity, which is what was mentioned here, cost per unit of electricity used. So now we know that the gradient of this line is 0.112 and the y-intercept is 60, so I can write the equation of the line straight. 0.112 is the gradient, positive 60 is the y-intercept. To locate another point for me to connect this point here to draw the line, what I can do is I can substitute x equals to 1000 to find the value of y. So when x equals to 1000, y will be equals to 0.112 times 1000 plus 60. You will get $172. So when x equals to 1000, y will be $172, which is over here. 172 is here, so you can draw dotted line all the way till you meet x equals to 1000, so over here. So I will then connect this point to this point to draw a straight line. So the orange line will be power save. This is how you do part B. Now let's move on to part C. So Mr. Lim is considering changing his supplier to PowerSave. His monthly cost of electricity will be cheaper using PowerSave if he uses more than a certain number of units of electricity. What is this number? So let's examine these two lines, okay? You'll notice that there is an intersection point. Let me just represent it in this pink color dot here. So there is an intersection point over here, represented by the pink dot of the two lines, okay? If you notice, on the left of this pink dot, PowerSave's line is above Spark Life's line. This means from 0 units of electricity to this particular point, this particular value over here, PowerSave costs more than Spark Life. On the right of this intersection, you notice that PowerSave's line is below Spark Life's line. This means from this particular units of value of units of electricity onwards, PowerSave will be cheaper than Spark Life, because take note, the Y values on this line lower than this Y values of Spark Life's line, which means the cost is actually lower. So what we need to look at, this part of the graph, PowerSave is cheaper than spark life. So let's look at this intersection point and find the corresponding x value using dotted lines down. You'll notice is 780 units of electricity. So for part C, the answer is just from graph 780. So this is how you do the entire question 2. Now let's look at question 3. So I'll give you some time to do this question. You can pause the video before you resume the video again to check your solution. So please pause the video now to try question 3 out. Okay, now I'll go through question 3, the solution for part A and part B. So for part A, how much does it cost to hire the digger for 4 days? So what do you need to do? Look at 4 days, dotted line up, dotted line across, and you'll get the value from your vertical axis. So from the graph, the corresponding cost will be $340 for 4 days. Let's look at part B. So the company charges a basic fee of $W. So this basic fee means at day 0, you already have to pay $120. So the y-intercept here will be 120, which is W. So X dollars per day. This means it is the gradient, because the gradient of this line will be cost over number of days. So to find the gradient, you can choose 2 points. Over here, I chose the y-intercept coordinates, which is 0, 120. And this point over here, which is 2, 230. I find the gradient, it will give me 55. So X will be equals to 55. Now let's take a look at distance time graph. This is the second section of unit 7.5. So let's read this first page. Consider a car traveling in the following scenario. So the distance from town A to town B is 50 kilometers. And then the car goes from town A to town B in 40 minutes. The car stops at town B for 35 minutes. And then last but not least, the car then drives back from town B to town A in 35 minutes. So actually, we can represent these 4 bullet points in a graph. This graph, we call it the distance time graph. Okay, it is a graphical representation to show journey where the y-axis is distance and the x-axis is time. So let's take a look at this graph already drawn for us on the right. Let me highlight to you which bullet point represents which part of the graph. So the distance from town A to town B is 50 kilometers. And the car goes from town A to B in 40 minutes. So let me just highlight this in yellow. So this straight line up actually represents these 2 bullet points, okay? 50 kilometers, 40 minutes. Next, when a car stops at somewhere, that means the distance doesn't change, okay? Which means in a distance time graph, it will be represented by a horizontal line. So let me just write here, represented by a horizontal line. Last but not least, the last bullet point, the car then drives back from town B to town A in 35 minutes. So it's this downward sloping line here. 35 minutes is traveling back from town B, which is 50 kilometers away from town A. You'll drive back to the starting point at town A. So this is how the 4 bullet points are represented by a graph. Now let's move on to the second part of this page, speed at a certain period of time. So in a distance time graph, the speed, also known as the rate of change of distance over time. So let me just write the formula here. Speed is actually distance over time. It can be represented in this triangle that most of you might have seen before, DST. So speed is equals to D over T. Okay? So speed is also known as the rate of change of distance over time. Okay? And then this is actually the gradient of the straight line in the graph that you are given or you need to draw. So take note, gradient of the distance time graph is actually the speed. So let me just write here in red. The takeaway from here is gradient of a distance time graph is actually the speed. Okay? So let's look at the last part of this page, okay? So from the distance time graph given here, okay? So take note, starting position is at A, you're driving to B. If it's upward sloping, if it's downward sloping, you're actually returning from B to A, okay? So positive gradient, let's look at this yellow line first. If you notice, this yellow line is an upward sloping line. It means the gradient is positive. It is moving away from town A, which is the starting point. Let's now look at this blue color horizontal line here. When it is a horizontal line, the gradient is 0. The object or the car, in this case, is at rest and not moving. Last but not least, this downward sloping line where the object, or in this case a car, is returning back to the starting point. Negative gradient, returning back to starting point, in this case town A. So take note, when it's a downward sloping line in a distance time graph, it means it is returning to its starting position. So this is what it means, okay? Positive gradient just means it's just driving away from the starting position. Last but not least, let's look at this formula on the last part of this page, okay? Very important formula, okay? Questions like to ask the average speed based on the distance time graph. So if speed, let me just go back to this formula. If speed is distance over time, then the average speed is just total distance traveled over total time taken. So this formula is very important. Let me just highlight it. Average speed, total distance traveled over total time taken. Now let's take a look at this GeoGebra animation that has distance time graph. So take note, the distance along road in meters is represented by the vertical axis. And then for time is at the horizontal axis, and the units is in seconds. So I already enabled the road on the left of the graph, so we can actually see how the car travels from 0 to 10 seconds. I'm going to press play. So as you see here, the car will travel all the way until 100 meters, and then it will stop for a bit, and then travel all the way to 200 meters. So let me replay it again. 0 seconds all the way to 4 seconds, it will stop for a while at 100 meters, and then continue on. So I'm going to enable the graph now, and then you can see how the car, as the car travels, how the graph is being plotted. So I'm going to press play again. So as you can see, at the 4th to 6th second, the car actually stopped for a bit. So that's why at 4 to 6 seconds, it's a horizontal line. So take note, from 0 to 4 seconds, it is a positive gradient because it is going away from the starting point. And at 6 to 10 seconds, still positive gradient because the car is still going away from the starting point. Now let's observe another GeoGebra animation with this car, the same as before, but now it will be traveling differently. Let's take a look. So all the way to 4 seconds, it will go back for a bit. towards the starting position, and then it will go away from the starting position again. So let me just replay it again. So it's going away from the starting position, and at 4 seconds, go back a bit, reverse back, stationary, and then it'll travel again. So let's take a look from 0 seconds with the graph. So how the graph is plotted based on how this car traveled. So at 4 seconds, you reverse back, and at 6 seconds, stationary, 8 seconds, traveling away from the starting position again. So do take note, when it's reversing back and it's going towards the starting position, there will be a negative gradient, downward sloping line from 4 to 6 seconds. And then if it's stationary, horizontal line, as you can see from the 6 to 8 second. And then at the 8 second, it continues traveling away from the starting position. That's why it is an upward sloping line to the 10 second. Now let's move on to the examples for distance time graph. Let's look at example 1 here. The diagram shows the distance time graph for a journey by a cyclist. So part A asks you to find the speed of the cyclist during the period represented by part 1 OA, part 2 AB, and part 3 BC. So OA, AB, and BC. So what we can do first, because to find the speed is actually the gradient, you need coordinates. So we can label coordinates for each point first. So A here will be 1, 20. B here will be 1.5, 20. And C here will be 3, 40. Now let's do A part 1. So to find the speed during the period OA, we need to find gradient. So speed equals to the gradient y2 minus y1 over x2 minus x1. Okay, so it will be 20 minus 0. So I'm using the y coordinate for A and the y coordinate for the origin over the x coordinate of A, which is 1, minus x coordinate of origin, which is 0. So you'll just end up with 20. Take note for the units, it will be distance over time. Distance unit is km, time is hour, so it's km per hour. Now let's move on to A part 2. If you notice, the distance here doesn't change. It is a horizontal line, so you can straight away write that speed equals to 0 km per hour because the cyclist was not moving. Last but not least, we have the speed for BC, so we can write speed equals, likewise, just find the gradient. Substitute the coordinates of B and C, so we'll have 40 minus 20 over 3 minus 1.5, and you will get 13.3 km per hour to 3SF. Now let's move on to part B. Find the average speed of the cyclist for the whole journey. So let me write out the average speed formula first. Total distance over total time. Okay, to find the total distance, what we need to do, we need to see where it ends off. So if you notice, the cyclist goes away from the starting point and away again, so it ends off at 40 km over here. So total distance is 40. The time taken will be total of 3 hours, and you will get 13.3 km per hour to 3SF. For example 2, please pause to try by yourself, and then when you're done, please press play to see the solution for example 2. So for example 2, okay, I will briefly go through. So for part A, the bus driver stopped to take a rest during the journey, which is this blue highlighted part here. How long was the stop? So if you zoom in, it's only half an hour which is 30 minutes. So answer for part A, 30 minutes. Now let's move on to part B. Calculate the speed of the bus from point A to point B as highlighted in green. So you can label the coordinates for A and B first, calculate the gradient, and you will get 40 kilometers per hour. So take note, I'm following the units given in the graph. Last but not least, for part C, find the average speed of the bus. So take note, the bus goes away from starting point, takes a break, goes away from starting point again to 160 kilometers, and then returns back to the starting point. So that means the total distance is 160 plus another 160. Total time is 5, so 160 plus 160 over 5, you will get 64 kilometers per hour as the average speed. So this is for example 2. For example 3, please pause and try part A and B on your own. It's similar to the questions in example 1 and example 2. Once you're done, you can press play again. So for example 3 part A, you have to find Mrs. Brown's speed during the period represented by part 1 OA. So you're looking at this line. So likewise, the coordinates of origin and A already written down. You can find the gradient and you will get 83.3 meters per minute. So take note, the units for distance is meters. Units for time is minutes. So hence meters per minute. And then for A part 2, you have to find the speed during the period AB. Likewise, I already written down the coordinates. So take note, because this is a downward sloping line, find the gradient first and you'll notice it's negative. The negative sign indicates Mrs. Brown is returning back to her starting point. So the speed, take the positive value, which is 55.6 meters per minute. Now let's go on to part B, average speed. Write the formula first, which is total distance over total time. Take note, because Mrs. Brown is going away from starting point and going back towards the starting point, you have to take 1000 plus another 1000. Total distance. Total time is 30 minutes and you will get 66.7 meters per minute. For part C, we have to describe briefly her journey as shown in the graph. We can use part A's answer. Let's look at OA. So OA here, you notice that the speed already calculated 83.3 meters per minute. So let me just highlight this blue part. Speed is 83.3 meters per minute. Okay, so you notice that Mrs. Brown walked at a constant speed. So over here, the speed is constant because gradient is the same throughout for 12 minutes. So we can write Mrs. Brown walked at a constant speed of 83.3 meters per minute for 12 minutes. That's the blue part. That's the blue highlighted part here. I'm going to highlight the other one in green. So to explain the part in green, we can also say that she walked at a constant speed of 55.6 meters per minute for 18 minutes. So 30 minus 12 will give you the remaining 18 minutes. So for the second part, you can explain it like so. So take note, the keywords will be constant speed, the values of the speed, and then the time taken. Now let's look at example 4. So take note, Betty walked from P to Q, which is 6 km apart. So over here is the distance time graph of her journey. Let's do part A together. So find her speed at 1430. So take note, 1430 is between 1400 and 1500. So over here. So do note that this is in the 24-hour time format. Okay. So this means from 1300 to 1400 is actually 1 hour. 1400 to 1430 is actually just half an hour. Maybe I'll just write half hour, which is better. Okay. So do note the units here for time is actually in hours. Okay, so find Betty's speed at 1430. So take note, this point is actually on this line here. Okay, so this point will have the same gradient as any point on the line here because they're on the same line. So what we can do to find Betty's speed at 1430, we can actually find the gradient of the line joining this point and also this point. That's where we'll get the speed at this point at 1430 as well. So let's write gradient equals to, I'm gonna write the coordinates of these 2 points down first. Okay, so take note, the x value will not be 1400, it will be 1 hour instead, because from 1300 to 1400 it is 1 hour. So this will be 1,6. Next up, this from 1300 to 1600 it will be 3 hours, so 3,0. So for part A, the gradient will be 0 minus 6 over 3 minus 1, and you'll get negative 3. So you can write hence speed is 3 kilometers per hour. So take note, I repeat again, negative is because Betty is walking back to the starting point. So as what I've written here, negative value for gradient because she's walking back to starting point. So do pause the video now to try part B and C yourself. Press play again to see the final answers and check your workings. Now let's take a look at part D of this question. So do take note, please check your answers and solution for part B and C yourself. For part D, now a new person introduced called Jackie walked at a constant speed of 6 kilometers per hour. Take note, this is from Q to P. Betty walked from P to Q. So I drew a diagram here for you to understand better. Town P, Betty walked from town P. Town Q, Jackie walked from town Q. So they are walking in opposite direction. Do note also, Jackie started walking 30 minutes later than Betty. Now let's do part 1. How long did it take for Jackie to reach P? Okay, how long, meaning the time taken. So let me just draw the triangle to represent the relationship of speed, distance, and time. Okay, so take note, to find the time taken is actually distance divided by speed. So D over S. So let me just write here. Time taken, distance over speed. So the speed of Jackie is given. Distance we also know as well, because question has given P and Q are 6 km apart. So 6 over the speed, which is also 6, and you will get the time of 1 hour. Now let's look at D part 2. We need to draw Jackie's distance time graph on the same axis here. Okay, so we have a crucial information already. We know that time taken for Jackie from Q to P is 1 hour, and he started walking 30 minutes later than Betty, which means he started walking at 13:30 because Betty started walking from 1300. So let me just mark where 13:30 is first. And Jackie finished the journey in 1 hour. So 13:30, 1 hour later will be 14:30. So let's mark the time out first. We know that Jackie started walking from Q, town Q. So town Q is 6 kilometers away from town P. So take note, the y-axis here is actually distance from town P. So at 13:30, he's actually 6 kilometers away from town P because he was at town Q. And then he finished his journey 1 hour later. He reached town P 1 hour later. So I can plot a point here, 13:30, 6 kilometers away from town P, which is town Q. And at 14:30, he reaches town P. So I can connect these two points together to form the line, and then I'll label this line as D part 2 Jackie's line. So that's how you do D part 2. So for D part 3, when and where did Betty meet Jackie? So they meet at the intersection point over here. So I'm just gonna draw dotted line down to the time axis to see what time they meet. So if you notice, it's about 3/4 away from 1300. So this 3/4 will just mean 1345. Okay, and then the distance here is halfway through 3 and 6, so it will be 4.5 because 6 minus 3 divided by 2 is 1.5. You can take 1.5 plus 3, you will get 4.5 kilometers. So the coordinates here will be, take note, 1345 minus 1300 will be 45 minutes. I'll just put 3/4 hour because this will be the time units is in hour. So 3/4, 4.5. Okay, so when and where did Betty meet Jackie? Betty met Jackie at the time 13:45 or 1:45 p.m. after Betty had walked 4.5 kilometers from P. So Betty had walked 4.5 kilometers from town P. So that's how you explain for D part 3. Now I'm going to go through section 3 of worksheet 5, which is speed time graph. So previously you've learned about distance time graph. Now we are learning about speed time graph. So it is another way of presenting a journey graphically where your speed is now the y-axis. Okay, so I'm just going to zoom into this second part of the page here. Okay, so take note, in a speed time graph, the acceleration, known as the rate of change of speed over time, can be determined by the gradient of the straight line at that time. So let me recall, gradient of distance time graph is your speed. Now, gradient of speed time graph is your acceleration. So there is a difference here as to what you're finding for the gradient of each of the graphs. So do take note, gradient of your speed time graph is your acceleration. So from the speed time graph, okay, we can actually know few things. When it is positive gradient, the one I highlighted in yellow, it means that the speed is increasing and the object is then accelerating. Okay, it's going faster. When it's zero gradient, which means horizontal line over here in the blue highlighted part, constant speed. Last but not least, I have a downward sloping line at the end, negative gradient, speed is decreasing, which means the object is decelerating. This means that you'll notice that maybe the object will be slowing down. Okay? So do note there are few units for acceleration. This depends on the units for the speed and the time given in the graph. Also, one more important thing that you have to know, okay, distance traveled is the area under the graph. I will go through a few questions that needs you to calculate the distance traveled of the object. Now let's look at example 3. For examples 1 and 2, please do it on your own and then check the solutions at the end of the video. So for example 3, we are given a speed time graph. Take note, speed here is meter per second and time is in seconds. So for A part 1, we need to find the acceleration during the first 10 seconds, which is this highlighted part in green. So do note, acceleration means it's the gradient of a speed time graph. So what you need to do, you need to find the coordinates of A and B and then calculate the gradient. Okay, to calculate the gradient of AB, you need the coordinates of A and B. Apply the formula and you will get 2. Hence, the acceleration is 2 meter per second square. Do note for the units here, you just need to see speed is meter per second, and then because you're dividing by time, which is in seconds, hence it is meter per second square. Okay, so speed is in meter per second, time is in seconds, so meter per second divided by second, you will get meter per second square. Now let's look at part 2, deceleration during the last 4 seconds. So let me highlight in blue the last 4 seconds, which is the section CD. Okay, we need to find gradient first, then we can find the deceleration. So deceleration here is when the gradient of speed time graph is negative. Okay, so let's find the gradient of CD first, and then we can find the deceleration. Okay, after you have found the gradient of CD, which is -5, because deceleration is the gradient of speed time graph being negative, since the gradient is already negative, I can straight away say deceleration is 5 meters per second squared. Notice there is no negative sign here. So for deceleration, the word accounts for the negative sign already. So deceleration, you can just write the positive value of the gradient. Now let's go on to part B. Describe the car's motion for the part BC. And if you notice, BC here is a horizontal line. Horizontal line means the gradient is 0, okay? Which means there is 0 acceleration. So the acceleration of the car is 0 meters per second squared from the time 10 seconds to 12 seconds. This also means, because if you notice it's a horizontal line, this means the speed from B to C is always constant at 20. Okay, so this is how you explain part B. BC is a horizontal line, gradient is 0, which means acceleration is 0 meter per second square, and the car is moving at a constant speed from 10 to 12 seconds. Now let's look at part D. Find the total distance traveled by the car. So total distance to find using speed time graph is the area under the speed time graph. So what do I mean by under? So let's look at the graph here. If you notice, BC, this line, is parallel to AD. So what I can do, since these two are parallel, if you notice, this is a trapezium. Okay, so I recap, area of trapezium is half times sum of parallel sides times your height of the trapezium. So if you notice, my height here is actually 20. And then my parallel side, so for BC, is from 10 to 12. So 12 minus 10 will be 2. And then my other parallel side is from 0 to 16. So this length AD here is 16. Let me write here 16. Okay. So to find part C, it will be half times sum of parallel sides 2 plus 16 times your height, which is 20, and you should get 180 meters. So this is the answer for part C. Now let's move on to part D. Find the average speed. So average speed, let me recap with everyone. Total distance over total time. So total distance, we can use part C's answer. Okay, part C answer. Total time, refer to your graph. It is till 16 seconds here. So total distance will be 180 divided by 16. Okay, and you will get an exact value of 11.25 meter per second. Okay, so take note for speed, the units is in meter per second as according to the graph here. For example 4, please pause and try part 1 and part 2 by yourself, and then press play again to see the solution for part 1 and 2 before I go through part 3. Okay, for part 1, just need to note is this green highlighted part, which is a horizontal line. So it is a constant speed throughout, t equals to 30 to t equals to 60. Part 2, find the acceleration for the first 30 seconds highlighted in blue here. Just need to find the gradient and you will get 0.2 meter per second squared. Now let's do part 3 together. After 80 seconds, so let me highlight keywords. After 80 seconds, which is from here onwards, after 80 seconds, Cheng slowed to a stop with constant deceleration. This means your gradient is negative. Okay, so it should look something like that. Okay, so from this point, it should look like this. It should be a downward sloping line, but I won't draw here because I don't know where to stop on the t-axis. Okay, question gave me another hint. Traveled a further 200 meters, find the value of t when Cheng stopped. Okay, I'm given distance, so do note distance is area under speed time graph. So I already drew a downward sloping line here. Okay, referring to the graph, I know that I need to continue from here. Do note that the height here is 8. So let me write here 8. What about the base? I do know I need to continue from here, which means it's from 80 to a certain value t lah. I don't know what this t is, I need to find. So this is from 80, then t. Okay, if you notice there is a right angle triangle here. This length will be t minus 80. So if you notice, because distance is the area under the speed time graph and the area here is a triangle. So let me just write here, area under graph is equals to the distance, which is 200. It will be the area of the triangle, so half times height times your base, which is t minus 80 equals to 200. Continue on, you'll get 4 times t minus 80. Divide 4 to the right, and then you will get t equals to 130. So this is how you do part 3. I recap again. Starting from the last part of the graph is a downward sloping line because of the word deceleration here. I'm given distance, which is the area under speed time graph. I can form an equation here. Half times height times my base, which is area of triangle, will be equals to 200. You can find the value of t. Do pause here to see the solution for example 1 after you have attempted, and solution for example 2 as well.